Welcome back, students. In my previous lecture, that is in lecture 2, I have explained about the elements of digital logic, that is basic gates, universal gates, logic design, functions of logic design with examples. In this video, I'll be explaining about the decimal number system.
Let us start with the decimal system. The decimal system contains 10 unique symbols. Which are the 10 unique symbols? 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. So these are the 10 unique symbols. And its base or radix is 10. And it is a positional weighted system. It is a positional weighted system. So what is a positional weighted system? What is the meaning of it? It means the value attached to a symbol depends on its location with respect to the decimal point. Like you have a decimal point, you have certain digits before the decimal points as well as after the decimal points. So according to its position, according to the position of the digit, it is having a weightage. So each symbol in the number is called a digit. Each symbol in the number is called a digit, and the leftmost digit in any number has the greatest positional weight among all the digits in that number. For example, you have this number point like this 0.72. So this is the leftmost digit which is having the greatest positional weight, and it is called as MSD or most significant digit. Most significant digit, and which is on the rightmost side. The rightmost digit in any number has the least positional weight among all the digits in that number, and it is called as LSD. LSD means least significant digit. Now the digits on the left side of the decimal point, this one for example, the digits on the left side of the decimal point is called the integral part. I'll write this once more. So this is the left part of the decimal. This is called as integral part, and the digits on the right side of the decimal is called the fractional part. This is the fractional part, integral part and fractional part. As I told, the digits to the right side of the decimal point have weights which are negative powers of 10, and the digits to the left side of the decimal point have weights which are positive powers of 10. That is, the first digit, this is the first digit to the left of the decimal point has a weight of 10 to the power 0. Anything to the power 0 equal to 1. 10 to the power 0 which is equal to 1. And the second digit has a weight of 10 to the power of 1 which is equal to 10. And third digit has a weight of 10 square which is equal to 100. Fourth digit has a weight of 10 to the power of 3 which is equal to 1000, and so on. Similarly, the first digit to the right of the decimal point has a weight of 10 to the power of minus 1. Then the second digit to the right of the decimal point has a weight of 10 to the power of minus 2, and if there is a third digit, the weight will be 10 to the power of minus 3. There is a fourth digit, the weight will be 10 to the power of minus 4, and so on. Let us consider this number 9256.26. So this can be written as 9 into 10 to the power of 3 plus 2 into 10 to the power of 2 plus 5 into 10 to the power of 1 plus 6 into 10 to the power of 0. That is, all these numbers, these are before this decimal point. Now after the decimal point, 2 into 10 to the power of minus 1 plus 6 into 10 to the power of minus 2.
The subtraction of the decimal numbers can be obtained by the nines and tens complement methods. The nines complement of a decimal number is obtained by subtracting each digit of the decimal number from 9. Suppose you have a 4-digit number, you have to subtract each digits from 9. The tens complement of a decimal number is obtained by adding a 1 to its nines complement. So in order to find the tens complement, the first step is you have to find the nines complement and then add 1 to it.
Let us do an example. Let us find the nines complement of the decimal number 3465. So first of all, let us check how many digits are there in 3465. 1, 2, 3, 4. 4 digits are there. So in order to find the nines complement, you have to subtract each digit of this decimal number from 9. So since there are 4 digits, let me write 4 nines here. Subtract this 3465 from this 4 nines. What you will get? What is 9 minus 5? 9 minus 5 is 4. 9 minus 6 is 3. And 9 minus 4 is 5. And 9 minus 3 is 6. So this is the answer that you get for nines complement. This is your nines complement of 3465. Another example. Find the nines complement of the following decimal number 782.54. This is very simple. It is similar to the previous one itself. What you have to do is you have to subtract this digit. How many digits are there before the decimal? 3 digits. 1, 2, 3. 3 digits are there, and after the decimal 2 digits. So therefore I have written here 999 with a decimal point, then 99 minus 782.54. Now you have to subtract this. 9 minus 4 is 5. 9 minus 5, 4. Then a decimal point. 9 minus 2 is 7. 9 minus 8, 1. And 9 minus 7, 2. So this is the nines complement of 782.54. Let's do another example. Find the nines complement of the following decimal number 4526.075. So how many digits are there before this decimal point? 1, 2, 3, 4. 4 digits. So let me write 4 nines here because I have to subtract this digit, this decimal number from these nines. And after decimal 1, 2, 3. 3 digits are there. So let me write 3 nines here. So I have to subtract 4526.075 from these nines. So what I will get? 9 minus 5, 4. 9 minus 7, 2. 9 minus 0, 9, a decimal point. Then 9 minus 6, 3. 9 minus 2, 7. 9 minus 5, 4. And 9 minus 4, 5. So this is the 9's complement of 4526.075.
Now to find the tens complement of a decimal number, first you have to find the nines complement of the decimal number and then add 1 to it.
Let us find the tens complement of the following decimal number 4069. So there are two steps to find the tens complement. First step is find the nines complement of the given decimal number, then add 1 to it in order to get the tens complement. So let us do the first step. First we have to check how many digits are there in this decimal number. There are 4 digits here. Therefore you have to write 4 nines, then subtract 4069 from this 4 nines. 9 minus 9 is 0, 9 minus 6, 3, 9 minus 0, 9, and 9 minus 4, 5. So this is your nines complement of 4069. Nines complement of 4069. Now in order to find the tens complement, you have to add 1 to this. Therefore you will get 5931. This is the tens complement of 4069. Now let us do another example. Find the tens complement of the following decimal number 1056.074. So here we are using a decimal point. How many digits are there before the decimal point? 4 digits are there. So let us write 4 nines here. Decimal point. After decimal point 3 digits are there. Write 3 nines. Minus 1056.074. 9 minus 4 is 5, 9 minus 7 is 2, 9 minus 0 is 9, decimal point, 9 minus 6, 3, 9 minus 5, 4, 9 minus 0, 9, 9 minus 1, 8. So this is your nines complement of 1056.074. Now what you have to do, you have to add 1 to this in order to get the tens complement. So when you add 1 to this nines complement, you will get 5 plus 1, 6, 2, 9.3498. So this is the tens complement of 1056.074.
To perform decimal subtraction using the nines complement method, obtain the nines complement of the subtrahend and add it to the minuend. Call this number the intermediate result. If there is a carry, it indicates that the answer is positive. Add the carry to the LSD of this result to get the answer. And if there is no carry, it indicates that the answer is negative. And the intermediate result is its nines complement. Take the nines complement of this result and place a negative sign in front of it to get the answer.
Let us do an example. Subtract the following numbers using the nines complement method. 745.81 minus 436.62. The first step is you have to find the nines complement of this subtrahend. So how do you find the nines complement? 999.99 minus 436.62. You will get 7, 3, 3, 6, 5. So this is the 9's complement. Now what you have to do is add this with the minuend. This is the minuend. So add this with the minuend. So 745.81 plus 563.37. So that you will get the answer as 81.903 and a carry is there. So this is the intermediate result. This is the intermediate result, and this carry, if you have a carry here, after this addition, if you get a carry, that carry should be added with this intermediate result. So when you add this carry with this intermediate result, you will get the answer as 309.19. So this is the answer with a positive sign. You should put a positive symbol here because you have a carry here. This is the rule for this 9's complement method. So this is your final answer. Let's do another example. Subtract the following numbers using the 9's complement method. 436.62 minus 745.81. So here the first step is find the 9's complement of the subtrahend, that is 999.99 minus 745.81. This is 81.452. What is the next step? You have to add this with the minuend. Minuend is 436.62 plus 254.18. 8 plus 2, 10. 6 plus 1, 7 plus 1, 8.096. Here there is no carry. Since there is no carry, what is the next step that you have to do? You have to find the 9's complement of this intermediate result. This is the intermediate result. Since there is no carry, next step is find the 9's complement of 690.80. So let us find the 9's complement. 9 minus 0, 9. 9 minus 8, 1. 9, 0, 3. So this is the 9's complement. Since there is no carry, you have to put a negative symbol along with the 9's complement. So this is the final answer.
To perform the decimal subtraction using the tens complement method, obtain the tens complement of the subtrahend and add it to the minuend. If there is a carry, then ignore it. The carry indicates that the answer is positive and the answer is final. If there is no carry, it indicates that the answer is negative and the result is its tens complement. Obtain the tens complement of the result and put a negative sign in the final result.
Let us do an example for the tens complement method. Subtract the following numbers using the tens complement method. 2928.54 minus 416.73. So here also what you have to do is, first you have to find the tens complement method. For that, first you have to find the 9's complement and then add 1 to it. So that have been done here. 99.99 minus 0416.73 will give you 9583.26. Add 1 to it in order to get the tens complement. So once you get the tens complement, you add that with the minuend. Minuend is 2928.54 plus 9583.27. 7 plus 4, 11, 1, 8, 1, 1, 5, 2, 1. So there is a carry here. So in this tens complement method, if there is a carry, you have to ignore this carry. And this itself is the answer. Ignore the carry and the answer is 2511.81. Answer is positive. Let us do one more problem based on the tens complement method. Subtract the following numbers using the tens complement method. 416.73 minus 2928.54. So the first step is you have to find the tens complement of this subtrahend. So you get the tens complement of the subtrahend as 7071.46, and the next step is you have to add this with the minuend. Minuend is 416.73 plus tens complement 7071.46. This is 98847. Here there is no carry after this digit. Therefore, the rule is, this is the intermediate result. The rule is, since there is no carry, you have to put a negative symbol in the final answer. And also, this intermediate result, this is not the final answer. You have to find the tens complement of this intermediate result. So this is the tens complement of the intermediate result, and with this result you have to put a negative symbol because there is no carry. Since there is no carry, you have to put this negative symbol along with the final answer. Therefore, the final answer is minus 2511.81.
Thanks for your time. In my next lecture, I'll be discussing about the binary number system.